Hi everybody, we're continuing to talk about solutions, and today we're going to talk about concentrations. So it is very important to express a concentration of a solution, meaning how much solute is in a given amount of solvent. It's very important to quantify that. So there's many different ways to express concentration. For example, biologists prefer to express it in terms of percentages, either percent by mass or percent by volume. Environmentalists prefer parts per million or parts per billion, and so on. In chemistry, the preferred method is molarity. So molarity gets the symbol capital M, and it is calculated as the moles of solute over the liters of the entire solution, and the units would be moles per liter, or capital M, which would be pronounced as molar. So if you see like a 3 with a big M, you'd say this is a 3 molar solution. So let's try a problem. It says, what is the molarity of a solution formed by mixing 10 grams of sulfuric acid with enough water to make 100 milliliters of solution? So since it's talking about molarity, we are going to write our molarity equation, moles of solute over liters of solution. Our solute is sulfuric acid. We need moles. We're given grams, so we can convert 10.0 grams of H2SO4. We're going to put grams on the bottom, moles on top. 1 mole is 98.1 grams. That's the molar mass of sulfuric acid. Now you can stop there, calculate that. That's going to be the moles, and then you take it, divide by the liters of solution, or you can do it as one big calculation. So that's what I'm going to do. I'm going to do one big calculation. So this is all moles of solute. So I'm going to divide that by liters of solution. We have 100 milliliters, so that would be 0.1000 liters. And you punch that into your calculator. You get 1.02, and this is either molar or moles per liter. Let's try another one. It says, how many grams of bromine are needed to prepare 0.5 liters of 0.01 molar solution of bromine in water? So this one's a more realistic question. When I'm doing a lab, let's say I need to make 1 molar copper sulfate solution for you, and I need a liter of it. Well, I want to know how much of my solid to mass so that I can make a solution for you. So since it's talking about molarity, we're going to start with the molarity equation again. So moles of solute over liters of solution. And in this case, they're not asking us for the molarity. They already gave us what the molarity is. The molarity is 0.0100 molar. So that's our concentration. They also give us the volume. They give us that it's 0.500 liters. So what are they asking for? Well, they're asking for the grams of solute, which we get by finding moles of solute. So we are trying to find the moles of the bromine here. That's our solute. Once we find that, we can find the grams. So that would be 0.00500 moles of bromine. They wanted grams though, so we're going to convert, put moles here, grams here. The molar mass of bromine, because it's diatomic, is 159.8. So that gives us 0.799 grams, and that's our answer. Now, chemistry is a lab-based science, and so it's important not just to do the calculations, but also to know how to make the solution in the lab. So when we are making a solution with a certain molarity, you need a volumetric flask. So let me show you what a volumetric flask looks like. So this is a volumetric flask. It is pretty wide on the bottom and narrow on top. And these volumetric flasks come in all kinds of different sizes. So there are really big ones and really tiny ones. So this, for example, is 25 milliliters, but they come in like little 5 milliliter ones. This one is 2 liters. You want to pick the one that is the correct size for you. So let's say we need to make a 250 milliliter solution, so you'd pick this one. That says 250 milliliters. Now notice it has one marking on it. That is the marking where you would reach that volume that's written, which in this case is 250 milliliters. So it's really good at measuring 250 milliliters or whatever volume it says on it, but it's really bad if you want any other volume. So you want to pick the one that is the correct volume for you. You also want to pick a stopper that fits before you start. And then you want to mass your substance. So I have a weigh boat here. I'm going to pretend that I'm massing it. This is copper sulfate. Let's say we're going to make a copper sulfate solution. So you obviously have to actually mass it, but I'm just showing you how to make a solution here. So you transfer your solid into your flask. Preferably it should be a dry flask so that it doesn't stick. The solid doesn't stick to the sides, to the neck, but it's not a big deal. You want to fold your weigh boat this way so that it goes in. And sometimes when you do that, there's still tiny little bits of the solid in here. So what you want to do is take your solvent. In this case, I'm just using water as my solvent. Put a little bit of the solvent in here, move it around so that you can dissolve it. And you can do that a couple of times until you get every little bit of it into your volumetric flask. And then you add water. Now when you add water, you don't want to add it to the mark right away. You want to add it, about halfway through the bulb. The reason why you want to do that is because if you add it all the way, it's going to be really hard to dissolve your solid. So you want to use distilled water. I just use tap water just to show you. But you want to add about half of it filled with water. It doesn't really matter how much, so that you can swirl, so that you have room to swirl. That makes it much quicker to dissolve your solid. And then once it's dissolved, then you can add more water. And the neck is very narrow, so it goes up very, very quickly. So I would recommend you can pour your water all the way to the neck, but then once you reach the neck, you want to use either a pipette or a squirt bottle. You want to be eye level with it, and you want the bottom of the meniscus to be at the line. So you fill it to the mark. And we notice that we did not measure the water. That's because we have the moles of solute that we measure, and then we have the volume of the whole solution, meaning the solute and the solvent together. So no need to measure the solvent by itself. You stopper it, then you invert it a few times. That way it all mixes, because if you don't do that, then it's more concentrated at the bottom. And that's how you make your solution. So let's write down the procedures for how you would write, or how would you make your solution, because you might be asked to do that on the test. So for this specific problem here, you would mass 0.799 grams of bromine and place it in a 0.5 liter volumetric flask. Fill it halfway with distilled water and swirl until the solute is dissolved. Add more water until the half-liter mark. Stopper and invert a few times. And that's how you make your solution. All right, so molarity is the preferred method for expressing concentration, but there are other methods as well. Another method is molality. So we have molarity and molality. Molality is not used as much in chemistry, so it doesn't get as much respect, and so we give it a lowercase m instead of a capital M. So molality is moles of solute divided by kilograms of solvent. So there are two differences here. It is not liters, it's kilograms on the bottom, and it's not the whole solution, it's just the solvent. So two differences. The units would be moles per kilograms, or little m, which you pronounce as molal. So if you see a 3 with a little m, that would be a 3 molal solution. Let's try this one. It says chlorine is often added to water in swimming pools and drinking water to keep the water clear and free of living organisms. What is the molality of a solution made up of 16.91 grams of chlorine and 5,000 grams of water? So it's talking about molality. So we'll write our molarity equation. Moles of solute over kilograms of solvent. Our solute in this case is chlorine. We're not given moles, we're given grams, but no problem, we can convert. So grams of Cl2, moles of Cl2. 1 mole, because this is diatomic, you add 2 chlorines together, so that is 71.0 grams. That gives you the moles of solute. Divide by the kilograms of solvent. Our solvent is water. We have 5,000 grams, so that is 5 kilograms. And the answer ends up being 0.0500 moles per kilogram or mole. Now, how'd you make this solution? In this case, we do not need a volumetric flask. Why? Because we know we can measure the solute separate and the solvent separate. So the solvent by itself is 5 kilograms, not the whole solution. So we use a volumetric flask when we do molarity because it's for the whole solution. But in this case, we do them separately. So in this case, we would want to use like an Erlenmeyer flask, a regular flask. So you'd mass your solute, or your solvent, put them together, stir or swirl, and that's it. So let's write that down. So mass 16.91 grams of Cl2 and place in an Erlenmeyer flask. Mass either 5 kilograms of water, or sometimes, we don't have balances that go all the way to 5 kilograms. You can also, density of water is 1 gram per milliliter, so you could say, or measure 5 liters of water. Place flask, swirl to mix together. So when it's water, you can, if you're given the mass, you can use the density to measure the volume instead. But either way would work. And the last way we're going to learn about today for expressing concentration is called mole fraction. Mole fraction gets the symbol X, capital X. And mole fraction is usually for the solute, but you can get it for the solvent as well. So I'm going to say mole fraction of substance A is going to be moles of A over total moles. Because it's a fraction, you take moles divided by moles, it has no units. So a mole fraction can go between 0 and 1. If it's 1, that means it's a pure substance. There is nothing mixed with it, so it should go somewhere between 0 and 1. Can't be over that. So this question says, what is the mole fraction of sulfur dioxide in an industrial gas containing 128 grams of sulfur dioxide dissolved in every 1,500 grams of carbon dioxide? So as you can see, it's asking about mole fraction. So we want mole fraction of the sulfur dioxide. So it's going to be equal to the moles of sulfur dioxide over the total moles. So moles of SO2 plus moles of CO2. We don't have moles of either, so we need to go from grams to moles for both of them. So I'll do that on the side. 128 grams of sulfur dioxide. 1 mole of SO2 is 64.1 grams. You can probably do that in your head. 2.00 moles of SO2. The other one is 1,500 grams of CO2. 1 mole of CO2 is 44 grams. This one's hard to do in your head. It's 34.1 moles of CO2. So, mole fraction of SO2 is going to be the moles of SO2, which is 2.00 moles of divided by the total, so 2.00 moles plus 34.1 moles. No units, because the moles over moles cancel. You get 0.055 as your answer. So we can express concentration in many, many ways. We learned about molarity, molality, and mole fraction.